Hi, in this video I'm going to go back and talk through the bonus problems from the Chapter 7 review sheet. Starting with this one, number 18. At 1 o'clock, two cars leave cities that are 417 miles apart and travel toward each other. One car is traveling 5 miles per hour faster than the other. They meet at 4 o'clock. How fast was each car traveling? So we're trying to find how fast each car was traveling. I can let x stand for one of those speeds, and then the other one was going 5 miles per hour faster than that, so that would be x plus 5. So maybe they were going 30 and 35, maybe they were going 90 and 95, but however fast one of them was going, if that's x, the other one would be x plus 5. So I set up my little table with distance equals rate times time, and I put x and x plus 5 in for the rates of speed of those two cars. We also know the time. They left at 1 o'clock, they got together at 4 o'clock, so how many hours were they traveling? 3 hours. One car was traveling 3 hours, so was the other. Once we have two of these filled in, we can use those to fill in the third one, and here we know the rate and the time, and so the distance would just be the rate times the time multiplied together. So 3 times x for the distance for one car, and 3 times x plus 5 for the distance for the other car. Now, since they were starting apart from one another and driving together, they started 417 miles apart and they drove together until they met in the middle. That means that the distance that one of them drove plus the distance that the other one drove should equal that total 417 miles. So that's where the equation comes from. 3x plus 3 times x plus 5 equals 417. So to go on and solve that, I'm going to multiply out 3 times x plus 5 to get 3x plus 15. Combine the 3x plus 3x into 6x, subtract 15 from both sides, and I get 6x equals 402. Then divide both sides by 6, and I get x equals 67. And then that's one of the two speeds, 67 miles per hour, and the other one would be 67 plus 5, which would be 72 miles per hour. So I found how fast each car was traveling. One was 67 and the other was 72 miles per hour. Another distance problem, a runner ran to the end of a track at a speed of 6 meters per second and then ran back at 4 meters per second. The total time to the end and back was 120 seconds. I could have just said it was 2 minutes, but since I gave the rates of speed in meters per second, I want to be consistent and give the time in seconds. Find the length of the track. So here, instead of two separate cars, we have one runner making two separate trips. Like the first trip is going to the end of the track, and then the second trip is coming back to the beginning. So I've set up my little table with those two trips to the end of the track and back, and I've labeled my columns for distance equals rate times time. Now here what I'm trying to find is the length of the track, and that would be the distance. If I start at the beginning and run to the end, I've gone however far that track is. That's my distance. So I used x to stand for that. The runner ran x meters to the end of the track, and then x meters back. We do know the rates of speed. We can go ahead and fill in those numbers. 6 meters per second running to the end of the track, and then 4 meters per second running back. We don't have a number for the time. We know it was a total of 120 seconds, but we don't know how many seconds the runner spent going to the end of the track, the first part of the journey, and how many meters were spent coming back. But once we have two of these filled in, we can use those to get the third. And here we have distance and rate, and so the time would be the distance divided by the rate of speed. So x over 6 and x over 4 are the times. Now the total time is when we add together those two times. How many seconds to get to the end of the track plus how many seconds to get back. So x over 6 plus x over 4 equals a total of 120 seconds. That's the equation we have to solve. It has fractions in it, so I want to kill off those fractions, and the least common multiple of their denominators, the smallest thing that's divisible by 6 and also by 4, would be 12. So I multiplied both sides by 12. 12 times x divided by 6 would be 2x, and 12 times x divided by 4 would be 3x. And then 12 times 120 would be 1,440. So when you combine the x terms, you get 5x equals 1,440. Divide both sides by 5, you get x equals 288. And since x stood for the length of the track, and that's what we were trying to find, that is the answer. The track was 288 meters long. And the last bonus problem was this one. We had one fractional expression divided by another minus a third. So there's both division and subtraction going on here. The rule for the order of operations says that division comes before subtraction. So first, I'll focus on the division. What do we get from x squared plus 2x minus 3 over x squared minus x minus 12 divided by x squared minus 1 over x squared minus 16. I'll focus on that to start with, and once I've done what I can do with that, then I'll look at the subtraction part of the problem. So I turned the division into multiplication by flipping the second fraction upside down. So now it's x squared plus 2x minus 3 over x squared minus x minus 12 times x squared minus 16 over x squared minus 1. Next, I factored everything in sight. The x squared plus 2x minus 3 factors into x plus 3 times x minus 1. That's what you would have to multiply out, x squared minus 1x plus 3x minus 3, to get x squared plus 2x minus 3. On the bottom, the x squared minus x minus 12 factors into x minus 4 times x plus 3. And difference of two squares here, this is x squared minus 4 squared, so it factors into x plus 4 times x minus 4. And the x squared minus the 1 squared factors into x plus 1 times x minus 1. Now the common factors that I can cancel are the x minus 1's on top and on the bottom, the x minus 4's on top and on the bottom, and the x plus 3's on top and on the bottom. The only thing left that didn't cancel was an x plus 4 on top over an x plus 1 on the bottom. Now I can look at what's going on with the subtraction. I also factored this denominator here, the x squared plus 2x plus 1 factors into x plus 1 times x plus 1, or x plus 1 squared. So now this is what I have to subtract, and for subtraction I do need a common denominator. To get these denominators to be the same as one another by multiplying by what's missing, I would have to take the first denominator and multiply it by another x plus 1. Then they would both have x plus 1 times another x plus 1. They would both be x plus 1 squared. So I multiply by x plus 1 on the bottom and also on the top of the first fraction. It becomes x plus 4 times x plus 1 over x plus 1 squared minus 2x plus 1 over x plus 1 squared. So if I multiply that out on top here, I get x squared plus 5x plus 4. Then I'm going to be subtracting the 2x and subtracting the 1, and it's all going to be over that common denominator of x plus 1 squared. Now I just combine like terms, and this simplifies to x squared plus 3x plus 3. That can't be factored. There's no common factors to cancel out. So that would be my final answer. X squared plus 3x plus 3 over x plus 1 squared. And it would be also be possible to write that denominator as just x plus 1 times x plus 1, or to multiply it back out and write the denominator as x squared plus 2x plus 1. Any one of those would be fine.